Welcome to Lean Into Excellence, a Workstream Consulting podcast. I'm Liz Crescenti.
And I'm Marco Bonilla.
And we will be your hosts as we embark on our continuous improvement journey. Welcome back to another episode of Lean Into Excellence. I'm your host, Liz Crescenti.
And I'm Marco Bonilla.
And today we have a very special guest with us. We have our very own senior consultant, Greg Masciana. Welcome to the podcast, Greg.
Oh, I'm glad to be here.
We are thrilled to have you. For the audience listening, do you mind sharing your background?
Sure. I'm a chemical engineer and a certified Six Sigma Master Black Belt with additional certification in lean manufacturing. I've worked on electronics for commercial satellites, the Space Shuttle and Mars rover, as well as military defense weapon systems such as Tomahawk, Copperhead, and Harpoon, in addition to the F-16 and Harrier jump jet aircraft. Recently, I designed and manufactured the liquid hydrogen and liquid oxygen fuel duct systems for the ULA Delta and NASA's SLS rocket ships.
Fantastic. What a background.
That's fantastic, Greg. Thanks for joining us today.
Well, I'm excited to be here today to discuss the benefits of the process capability approach.
Yes, we're going to do a deep dive into that, so get ready.
Hey, Greg, it's fantastic that you're here. Tell me a little bit more about process capability and why it's important.
Sure. I've often been contacted by companies seeking to improve their profit margin or needing assistance resolving issues with their customers. Regardless of whether those issues were related to quality problems or on-time deliveries, they want help, and they need it now. One universal truth that I emphasize is that one or more processes must be improved in order to fix anything. Every issue, every problem has a cause, and that cause is a process that needs updating. If you don't break eggs, you can't make an omelet. The key to success is to identify exactly which processes to address and which steps within each process to modify. In an earlier podcast, we heard all about process mapping. So here's the path forward. Determine the capability for every step on that process map. If you know the specifications or even just your expectations, you can measure anything to get the process capability of that operation. Everyone knows that change is hard, but knowing where to start is actually the first challenge. This podcast is all about using the concept of process capability to identify and monitor process improvement.
Absolutely. Knowing where to start, that can absolutely be the most difficult part of the equation. So we're excited.
Greg, you bring up a really good point, right? So every step in the process has an effect to process capability, right? So from beginning to end, you just can't focus on the very last step, because the very last step was probably had the least effect on the process.
Right. Just because final inspection says it's bad, you have no idea where that happened.
Exactly. It could have been 20 steps prior.
Right.
Right. So you got to turn over every stone in that case.
Correct.
You know, Greg, process capability can mean different things to different people. How would you define it?
You're right. You're absolutely right. I'll define process capability as the metric that describes how effectively a system of operations, like from the process map, provides the desired outcome. The benefit of this approach is that in addition to rating the overall process, the capability metric identifies exactly which process steps are most urgently in need of fixing, as well as enabling clear numerical tracking of the impact of each and every process change. A bonus for adopting the process capability approach is that the metric will signal when each process step has been optimized enough so that efforts can then be redirected to the next process on the priority list. I encourage all companies to launch a successful improvement program by first determining their process capability. I have seen successful companies build their entire business around determining the capability metric for each step of every process to gain an accurate understanding of exactly where to target upgrades.
Greg, that's fantastic. Can you kind of do a deeper dive on what the process capability metrics are and how are they important to the company?
Yeah, that's a key thing. This word, the metric, right? The number. How are we
Right.
going to measure the thing that we're talking about instead of just having a feeling?
Right. Because you can't, if
That's
you
where
don't
we
measure,
want.
you can't improve, right, Greg?
Exactly. Just say I don't like it. Well, it's hard to improve that, right?
Right. Or it doesn't feel right.
Yeah,
That's not
and
enough.
and how can you say one thing is more in need of help than another part of the process?
Yeah, you
That's
can't go off of a feeling.
yeah. We need metrics. We need numbers to talk about,
We
right?
need a baseline of some sort, right?
Yeah. So the process capability metric. Actually, there's two capability metrics that are typically used in an improvement program. CPK, it's capital C and then a small pk, is the short term ability of a process to meet a specification, while PPK, capital P, small k, PPK is how a process actually performs in the long term. CPK is for tracking impacts of day to day process adjustments. And then PPK provides the ongoing performance that the customer will experience. In today's podcast, we're going to discuss PPK, because that metric is very easy to calculate with Microsoft Excel. No special statistical software is needed. So, for the whole rest of today, we're going to be talking PPK, something that everybody with Excel could do for themselves.
Perfect.
Hey, Greg, can you give us a couple examples of acceptable versus alarming metrics?
Sure, a poor PPK metric would be anything less than 1.33, typically indicating too much process variation, as well as a process running too close to either the upper or the lower specification limit. Many end use customers expect the PPK of delivered products to be greater than 1.67. This is so that there's some margin between just barely capable, and really capable day in and day out. And the gold standard of a process, the fabled gold standard, right? The ideal process, the Six Sigma process, is a PPK of 2.0, which predicts only 3 defective units out of every million units built.
Hey, Greg, I have a question to follow up with that. Our audience might be made up of from different industries. Is there an industry specific difference between what the PPK should be?
Not really, because we're talking about capability and we're talking about a process and how well it will perform for everybody. And it doesn't matter whether that process is drilling a widget or whether that process is filling out a form on a computer screen. We want the process to be predictably wonderful all the time.
So,
And
regardless of
that
the
means
industry,
we
the
want a
higher.
good PPK.
Right, right. So, regardless of the industry, the higher the better.
Yes,
Right.
yes, the higher the better. We want a good PPK, and that's what's wonderful about the PPK metric. Anything if that you can measure, you can get a process capability number, and you need a big number. Small numbers mean there's a problem with your process. The
Right.
customers are not going to be happy.
Absolutely. That's a great point, Greg.
So now that we understand what a good capability number is, how would we go about calculating that?
Now we're talking about where the rubber meets the road, right?
Yes.
Where do we get the
Yeah,
number?
exactly.
That's where we'll need some tools. But first, we must collect a column of output data from the products of a process. About 30 measurement data points is usually a good start, but that's not a hard and fast rule. The data you got is the data that we're going to use. An Excel spreadsheet, I'm getting back to that Microsoft Excel that just about everybody has on their computers. An Excel spreadsheet can easily perform the straightforward calculations for averaging and for overall standard deviation. Now, standard deviation is the amount of variation in the data. Yeah, it goes up and down or left and right or whatever it is, and Excel has a little built-in formula for coming up with standard deviation. Now, Both of those terms, the average and the standard deviation, are necessary to determine that PPK metric, which is simply the difference between the average and the closest specification limit divided by 3 times the standard deviation. That's easy in Excel. You take an average, you subtract it from the limit, you divide it by 3 times the standard deviation, and you have a PPK number. Note that for CPK, remember that's that other capability metric? Remember that one, the other one? The one we're not going to talk about today? Note that for CPK and for specialized cases involving attribute counting types of data or non-normal skewed distributions of data or subgroups of data, such as taking 5 measurements every hour, to do any of those special things, you'll need statistical data analysis software such as Minitab, QI macros, or Sigma XL to calculate the CPK metric for your data. So for today, we'll just stick with Excel PPK, okay? And that's the long-term process performance metric.
I think that's a great idea, Greg, because we might be here all day doing a deep dive, right?
Exactly.
I think a lot of the audience would prefer Excel over Minitab, but that's just me.
Well, it's most accessible, right? I mean, most people have access to Excel.
You already have Excel. You don't have to go out and buy anything.
Right. This
exactly.
isn't exactly. So use the tools that you have in front of you. This isn't create more cost. For
As Marco said, you don't have to make a science project about it. So
exactly.
Yeah.
There's a need for Minitab when it's needed, but not right now.
Yeah, there are some special circumstances and blah blah blah, and maybe you'll hire somebody to help you with those. But my point here is capability is for every man. Everybody can do capability, and all you need is Excel. It's actually quite straightforward.
And should do capability as we talked about, right? It shouldn't be a feeling or a guess.
Right, everybody should be doing it.
Yeah,
and
you should know where you are in the world. Exactly.
Right. We don't want a barrier. We don't want to tell people, you got to go out and buy software for $200 or $1,000 or whatever these software, programs cost these days, right? We don't want to tell people you can't do capability because you don't have the money to buy extra software.
Yeah.
We want
exactly.
To tell them, you should be doing capability because it doesn't cost you anything. You already have Excel.
Exactly. and non-financially, you can't afford not to do capability, right? Because you can't improve if you don't know what your baseline is.
Exactly.
So let's talk about some examples, Greg. There's probably a million examples out there, probably a ton that you've used capability analysis on. But can you give us a couple of examples that come to mind?
Absolutely. Well, there's hundreds of examples, but we don't have all day, right? So here's a couple. We could do more podcasts, right? More examples.
Part two.
Just examples.
I know. So actually, here are a couple of my favorites. The new modernized heads-up display for the F-16 fighter jet was a wonderful electronic masterpiece. Everybody loved it. But the electronic module for it was mounted close to the plane's M61 Vulcan Gatling gun. When firing at 6,000 20-millimeter rounds per minute, vibrations were so severe that electronic components were actually knocked off the circuit board.
Not surprising at all. You should have seen that coming a mile away, Greg.
Exactly. And keep in mind, so the idea was we had to fix the problem, because then the pilot would say, the head-up display was working until I fired my guns, and then it stopped working. So that's the kind of customer complaint.
A little problematic.
It's a one and done, pretty much, right? It's right.
You don't want that kind of customer complaint from a pilot, right?
Yeah.
In a fighter jet. So anyway, so it had to be fixed. Now, the interesting thing was, they told us we had to fix the problem, but we're not allowed to change the electronic design of the module. Now, can you imagine? You have to fix the problem, but don't change anything.
I get that all the time, Greg. In my history, it's just they expect this magic dust or this magic wand. Don't touch my design, but
sprinkle foo-foo dust on it,
exactly.
Right?
You mean that doesn't work?
Just put some duct tape on it. You'll be okay. Duct tape fixes everything.
So here was this. So the solution came forth finally after a lot of things were tried. Epoxy was used to secure the components. Glue them down with epoxy, right? But the epoxy viscosity across the entire module had a lot of variability in it, and there were actually too many failures. It certainly made things better, but there was just too many failures, too many customer complaints, too many pilot complaints.
Yeah, quality is one and quality consistency is the other, right?
Yeah, exactly. So it kind of helped, but it didn't fix the problem, right? The initial PPK of this epoxy process was only 0.9. Remember I said we want at least 1.33? Remember that piece?
Yeah,
This was
0.9
only
is
0.9.
that means there's a large fallout in your capability.
Right. So different formulations were tested. And, mix this, mix that, mix it this way, mix it that way, cure it this way, cure it. All those process parameters for epoxy mixing and curing, right, were tested until finally an acceptable capability metric was achieved. And when that happened, the pilots never again noticed a problem. So that was that. That's that. There's aerospace planes, right? Another example was to optimize the weld quality of the Inconel superalloy used in liquid hydrogen and liquid oxygen fuel ducts for modern rocket ships. Now, these are rocket ships. Some are unmanned rocket ships that just launch satellites, and some are the upcoming manned rocket ships that are going to go to Mars and the asteroid belt, right? So this Inconel is really difficult to weld. I got to tell you, it's called a superalloy because it has all kinds of special properties, and I like to say special properties that make it almost impossible to weld. So this was a big deal, and as you can imagine, there were many welding process parameters which must work in concert to produce the perfect welded joint. What we did here was made a process map of the welding process and then optimized the capability metric of each variable in the weld process, one after the other, perfecting one variable, move on to the next one, get the PPK for the next variable, move on to the next one, get the PPK for the next variable. And those variables for the welding machines could be, the voltage going into the weld, the amperage going into the weld, the temperature of the environment, where the welding was happening.
How long,
the amount
right?
of oxygen.
Greg, how long you were doing the weld? Yeah.
Yeah, exactly. All those things,
Sure.
one after the other. Get a good PPK, get a good PK, get a good PPK, until finally they were every process variable, every adjustment that the operator could make was perfected, right? And then I was going to say like magic, but it wasn't magic. It was a lot of work, right?
Right.
And then these welds would pass finally every NASA test.
Greg, I appreciate you plugging process maps again. So people go back to listen to episode 2.
Episode 2. Yes.
Right.
Great.
Well, it's
with our own Doug,
right?
Yeah.
Shout
a
out
lot
to
of people
Doug.
say, well, here's a flow chart of what we do. But now what do you do with that? Just having a flow chart of what you do, is really only the first step in process improvements.
Absolutely.
Yeah, it's the knowledge. Now you got to execute.
And now exactly the right thing, Liz. We have to execute on that process map, and that's where process capability metrics come in.
So, Greg, I am concerned. You used 2 examples that seem like you need top secret clearance to be like an entire. Hopefully, we're not going to be.
Let's dumb it down a little bit.
Hopefully, the government's not going to come after us for sharing some of this information.
He is the professor.
Yes,
it's public knowledge.
That was
Greg?
my nickname at 2 previous companies.
But it's public knowledge, I hope.
That's true. Well, you know what? I mean, those are high-end aerospace rocket ship kind of examples, right? But remember I said process capability is for everyone?
Absolutely.
So let me give you some commercial examples that have nothing to do with rocket science, right? And this is not rocket science. These are commercial companies. So there was a large commercial company that produced custom corporate branded swag. You've probably seen it, right? Mugs and pens and notepads, and these people made umbrellas with the company logo
We love
on it.
swag. It's
Technically, well,
something
I
we
Amazing.
think
all
I think all
get.
three of us are wearing swag right now, right?
Yeah, exactly. Exactly. That so, and they did this at high volume, right? And and they what they wanted to do was increase throughput. They were getting a lot of business. They had people working shifts well into the night, a huge amount of overtime, keeping. I mean, so on the one hand, you have a company making had a lot of business, right? Getting a lot of orders, making a lot of profit, but they were really stretching their workforce into these to working super long hours, and people get tired of working super long hours, right? And so they wanted to increase throughput so that there could be like weekends off, maybe something unheard of
Right.
at this company.
What a luxury.
Imagine
I
that.
mean, you can't have a weekend off if we're behind on filling the orders. So the idea was don't be behind on filling the orders because we had higher throughput all week long. You see, there's a motivation
Right.
behind here, right? So in this case, there were thousands of part numbers, all these company logos, right? Hundreds of operators, scores of machines in this gigantic factory. It's like 300,000 square feet. I mean, a huge place. What we did is we started just like I said. We used capability to identify the processes with the worst performance against specifications for two things, both for quality and for production speed. So we had a spec for how good quality each item had to be, and that's like it had to pass the test, it had to pass the inspection, whatever, right? But also we said, here's the goal for production speed. Remember, I said the metric capability spec can be an expectation as well.
Absolutely.
So we also had production speed. How many minutes should it take to make one of these things? Or
If everything was
and so
perfect,
we
though,
had
Greg, right? If everything
yeah,
was
so we had
perfect,
two PPKs. We had a quality
right?
PPK for how good is the quality of the product, rework, blah blah blah, and then we also had a speed PPK. Are we making it fast enough? So we actually had two PPKs for each thing there. Uh, there were a lot of key variables to address. The hardest one was the mixing of the printing inks to achieve exactly the right color shades for corporate logos. Customers were extremely concerned about that because they were I mean, this is like they're putting themselves out there, right? And the
Yeah, it's their
slightest
branding.
shade, this blue doesn't look like that blue, right? And so, and this whole mixing routine, had to be really right, right? So what we did was, we focused all the improvement efforts until each of those processes had acceptable PPKs. The ink mixing,
Right.
everything else, right? Application, curing, yeah, and everything. Now, this process wasn't overnight, as you could well imagine, right? It went on for several months, and during that time, interestingly enough, we were trying to increase throughput, right? But while we're doing it, the customer demand also increased because the sales department decided to optimize their process at the same time, so that the manufacturing group wouldn't get all the glory.
No doubt. No doubt,
So
Greg.
that was kind of it was an unexpected consequence,
Yeah.
right?
And just to reiterate what you're saying, Greg, before you make things move faster, you need to improve the quality first, right? Because if you make things move
Right.
faster, all you're doing is producing more non-conforming, right? So quality over
Exactly.
speed first, and then once you get the quality down to a science, then you can tailor your speed until you don't damage, right?
Yeah. Yeah, I've got a great example for that. Going faster and not paying attention to quality. There was another strictly commercial company that made pumps for swimming pools. They had been trying to reduce warehousing across the country by implementing just-in-time lean manufacturing.
Great. We have not
They had
introduced just in time yet, but this is great, Greg. This will be a future podcast.
I know.
Yes, we'll dive
You know,
into that.
so at this swimming pool pump company, they had very pretty U-shaped lean cells with everybody standing at their machines, and It was they had videos about how wonderful this all was. These were lean cells for making several part numbers, one piece flow. That's a lean manufacturing term, right? Yet they were still struggling to keep up with customer demand due to inconsistent quality. In other words, they were very efficiently, very quickly making pumps that needed rework. So that's exactly what you said, right? You can't just focus on quality, on speed and not quality, or quality and not. You have to have both.
And the question always comes, Greg, if you didn't have time to do it right the first time, why would you have more time to do it the second time, or rework, in other words, right?
Right, the second time.
And it adds cost, right? That process adds cost.
Time, cost, resources,
And some of their operations were actually okay, but they were failing because of too much variation in earlier steps of the process. So it was complex, right? Some an operator would say, "I'm doing my job just right." It's just that person, 2 hours ago with their process, they're handing me all this stuff, and I'm, it just doesn't work, right? This is where process capability comes into play, right? You get the PPK of every single step in the process, right?
Okay, so I think we're sold on the value here, but can you go into some specifics about exactly how to set up and conduct a process capability study?
Yeah, and this is where a lot of times you see articles and on the internet or whatever about you should do this, you should do that, and I'm saying you should do capability, right? They often stop short of where we're going today. How do you do it?
The mechanism.
That sounds great, but how?
Right?
When
We're not just talking about what do you do? Why, right? We're talking about how do you actually go about doing it,
right? And doing it well the first time.
So just to show that every process can have a capability metric, in order to show you how to set up a capability study, right? Consider a new teenage driver, the family car, and a 2-car garage with a large post in the middle.
This sounds nightmarish.
Nightmare. Each garage entry width is only 6 inches wider than the side view mirrors that stick out on the sides of the car. That's only a 3-inch margin on each side, if the car is perfectly centered. So now what I did was put pieces of blue painter's tape at the center of the bumpers and at the center of the garage. It was easy to measure by how much my daughter drove the car too much to the left or right of the center mark. Many attempts later, and she never hit the mirrors once, but many attempts later, capability was calculated in Excel, showing a poor PPK of 0.8 due to too much variation in parking efforts, even though the side view mirrors never actually touched the garage entryway.
But they made you sweat, though, Greg.
Yeah,
they made you sweat.
because
that's the measurement
capability indicated that unless there was dramatic improvement, sooner or later, a mirror was going to get hit.
Yeah, absolutely. That's a one-time event, too, right?
Really.
Destructive testing.
Did we want high capability? You betcha, right? What I did, I promised to buy my daughter a car if she could achieve a capability of at least 1.33.
Wow.
I think all parents
anyone would.
Yeah, every
Right?
podcast, everyone listens to the podcast.
Greg, can you be my dad? That's amazing.
Exactly. So Greg, that's great, because everyone listening to the podcast try and figure out how to incorporate process capability with their children.
With teenage
your everyday life, yes.
Right. Anyway, so what she did was she put a vertical strip of blue tape in the center of the back wall of the garage, then aimed for it during subsequent parking attempts.
Target practice. Yeah.
She earned her very own car. It was used, but she was happy.
That's okay.
That's fantastic. What a great story.
There's no damage to the garage, right?
Everyone's happy.
Right. So now you're going to set up a project, right? So now it's time to check to see if the new set of tires she just bought will truly last for the 70,000 advertised miles. With this podcast, you can now set up a capability study. Measure the new tread depth subtract 2/32 of an inch to get the usable tread depth. That's the legal standard, right? It has to have at least 2/32 left, right? And then divide by 10 to calculate the maximum tread loss spec if you plan to check the tires every 7,000 miles. So 7,000 miles times 10 checks, that's your 70,000 miles, right? Now, to measure tread, you'll need a tread gauge. Amazon has them. You can buy all kinds of gauges at Amazon for tread depth. And be sure to measure at multiple locations all around
Right,
each
to
tire.
make sure it's balanced, right,
Yeah,
Greg?
well, right, because you want to measure the middle, you want to measure the edges, you all around, right? And this will, by the way, this will give you lots of data points for your Excel. Remember, I said make a column of data. You'll get a lot of data points every time, and there's 4 tires on the car, so you'll get a lot of data points of each tire and 4 tires on the car. And every 7,000 miles, you take your Amazon tread gauge and you measure. What you're really going to do is you're going to enter the tread loss data since the previous check, right? How much tread did you lose against how much tread is okay to use, based upon, a tenth of 70,000 miles. Every 7,000 miles, then you can update the PPK to get an idea of the likelihood of these tires achieving the advertised 70,000 mile tread life. This is a fun capability study you can do at home.
Yes, and if you get it correct, Greg will buy you a new pair of tires.
He'll buy you new rims.
Yes.
Hey, Greg, here's a fun fact for you. Maybe you don't know this, but I think it was last year or the year before. You think field goal kickers are very accurate to a field goal post, right? When they do extra points or 3-point kicks after, scoring in a football game. There was a Cowboy kicker, I think last year or the year before, that missed 4 extra point field goals in one game. What do you think the capability of his analysis was? So just to give you an idea, that hasn't been done in 90 years. So this was really a one-off. But this actually happened during a playoff game. They still won, but I know that kicker was sweating because his capability analysis turned out really bad.
Yeah. Now, see, what I would have done as a coach is measure how far off center each kick was in practice. And if you could see what the variability in practice was, you could use PPK to predict what's the probability that you can actually miss the goal post altogether.
Well, Greg, in fairness to him, I think he hit almost every field goal during the regular season. I think the stress of being in the playoffs, I think, got to him.
He choked.
Yeah.
No, the point is not, did the rear view mirror not hit yet? The point is how much variation was there,
so you can compensate.
That variation is what's going to predict that badness will happen at some point in the game in the future.
Right.
It's the variation that's important. So it could have been he could have kicked it 100 times and never missed it once. But if the variation was poor,
the predictability,
the PPK will indicate a high probability that he's going to miss it in the future.
So, Greg, where were you when this kicker was? Well,
if they'd hired me, I would have.
He needed to be on the sidelines there.
We'd have it set, and then we could compare the PPK of the different kickers.
Get the whiteboard
because every team has more than one kicker, right?
Yeah. Well,
you have to decide who's going to be the prime time kicker, who's going to be the backup.
Right.
Oh, well, I would say the higher PPK goes to the prime time kicker.
Sure.
I'll make mathematics out of this issue.
As it should be, right? You remove all emotional bias.
Right.
Excellent. So, Greg, just to close out the podcast, do you have any final thoughts you want to share with us regarding capability analysis?
Yeah. Process capability is the only statistical data analysis tool that will also predict the future. And you'll need software packages for this piece, but they can predict the long-term reject rate in either percentage or parts per million based on the current process capability. And this is what I was talking about, like with the football game or with the tire tread, right? Or with parking in a garage, or this prediction, right, is just really key piece of process capability. And it's the only tool that will do that. Finally, I guess my last comment would be, if you can measure it, you can calculate its process capability. And the specifications don't have to be dimensions such as length and width or temperature degrees or angle degrees or pounds or grams or ohms or volts or any of those things. You can actually use time, minutes to complete a task, seconds to do this, hours to finish a unit, right? You can use time to be a measurement spec for capability.
Absolutely. So kind of in summary, in comparison to, maybe let's talk about the stock market real quick. This is a leading indicator. It can actually predict. It won't tell you when, but it will happen if it's outside.
It'll give you a probability.
Exactly.
Yes.
Like percentage, like how many bad units out of 100, how many bad units out of 1,000.
Exactly. So you'll see it coming. There won't be any surprise.
Exactly.
Well, thank you so much, Greg, for joining us today. This was beyond informative.
Yeah, it was fantastic having you, Greg.
Well, I just hope we'll provide guidance for how to develop, for all the listeners, how to develop your very own process improvement efforts. And the message here is, you want to improve something? Start with PPK. Start by understanding the capability of the thing you want to improve. And then every time you make some kind of improvement, collect some more data and see what the new PPK
Right.
is. And you can actually watch the PPK climbing. Maybe it starts at only 0.8 and then it goes to 0.9. It's not good enough, but it's better.
Yeah.
And then it goes to 1.1. Still not good enough, but it's better. And then it's to 1.3, and then you decide, no, we're doing medical devices. We 1.33 is not good enough for us. We need 1.7 or 1.9 for a medical device.
It will also,
but at least you have numbers.
Yeah, and it'll also tell you if you're making improvements. It's possible you go in the opposite direction. So it's going to stop.
Right.
It's going to stop whatever improvements you're working on that you think it's helping.
Oh, that's true. So, and that's happened where a company thinks they're making a change. Somebody says, some engineer will come along and say, "Well, here's what we should do.
Right.
Make this change." Right. We're gonna cure it at 150 degrees instead of 125 degrees, and that's going to solve the whole problem.
Right.
Watch the PPK, and sometimes it goes backwards.
That's right. Stop what you're doing.
Sometimes it goes down.
Exactly. You're not creating more chaos in this case.
Right. But isn't it nice to have a metric? I mean, everybody can see that 0.9 is worse than 1.1, right?
Yes.
I mean, that metric makes it real easy to understand. Did I make the process better or did I make the process worse?
Exactly, Greg. Well, this has been fantastic. We're going to have to get you back on. So, Greg, let me ask you something. If someone wants to reach out to you, what's the best way of getting a hold of you?
Workstream Consulting.
Awesome.
Yeah, so I would say feel free to reach out to us if you have any questions, or Greg, and you can find us at workstreamconsulting.com or info@workstreamconsulting.com. And just a reminder, new episodes are released every other Wednesday, and we will see you next time. Thanks again, Greg.
Thank you, Greg.
It was my pleasure. I had lots of fun.
Fantastic.